Welcome to the deep dive. Today, we're jumping into the world of 3D printing.
Yeah, specifically looking at two quite popular machines from Bambu Lab.
That's right, the A1 and the X1 Carbon, or X1C, as people call it.
Mhm.
Now, maybe you're already deep into printing, maybe you're thinking about an upgrade, or perhaps you're just, curious about what this tech can do.
Right. Lots of possibilities.
So our mission today really is to go through the specs, the product info we have from Bambu Lab's site,
Yep, the official pages.
and really pull apart what these two printers offer. What are the
Yeah.
key differences? Who are they for?
Exactly. Sort of figuring out the positioning, the strengths, the weaknesses, maybe.
Hopefully by the end, you'll have a much clearer picture, whether you're looking to buy or just want to understand the tech better.
Sounds like a plan. Where should we start?
Yeah.
The A1.
Yeah, let's start with the A1. Bambu Lab calls it the colorful gateway to 3D printing.
Okay, so Gateway definitely suggests accessibility, ease of use, and colorful is pretty self-explanatory.
Right. The big thing here seems to be multicolor printing with something called AMS Light.
Ah, yes, the AMS Lite. It's their system for handling multiple filaments on the A1.
How does it work, basically?
Well, it lets you load up to 4 different colors, or materials, though mostly colors, and the printer automatically swaps between them during the print.
4 colors max, then.
4 colors max, yeah. It uses one AMS Lite unit, and that's the limit for the A1.
And it's only the AMS Lite, right? It doesn't work with their other standard AMS system.
Correct, that's a key point. The standard AMS you might see with the X1C, that's incompatible with the A1. This is specifically the Lite version.
Got it. So multicolor is a feature, but it's capped at 4 with this specific system.
Exactly. And they say it's reliable, even has RFID readers for Bambu filaments to auto-load settings, which fits that easy gateway idea.
Okay, that makes sense. Another feature that jumped out at me was the full auto calibration. What's that actually involve?
This is a big one for ease of use. Before every single print, it automatically calibrates a bunch of things.
Like what? Bed leveling?
Bed leveling, yes. Also the Z offset, that's the nozzle height, plus vibration resonance, and even the nozzle pressure.
Wow, okay. So it's really trying to eliminate all that manual tweaking you often have to do.
Pretty much. They call it absolutely hassle-free. And doing all that automatically before each print is, well, it's designed to ensure consistency. It's like tuning an instrument before playing.
That's a good analogy. And I guess that leads into their one-click-to-print concept.
Yeah, it seems connected. If the machine handles all the calibration, you can, in theory, just pick a model, maybe from the MakerWorld platform, and hit print without much fuss.
Simplifying the whole workflow.
Definitely lowers the barrier to entry. You
Yeah.
find something cool online, click, and hopefully get a good print without needing deep technical knowledge.
No, just because it's easy doesn't mean it's slow, right? They talk about high-speed performance.
No, not at all. They mention things like low-drag linear rails.
Right, what does that mean in practice? Smoother movement.
Yeah, smoother, more precise movement, which allows for higher speeds without shaking itself apart, basically.
Yeah.
They also mention a powerful MCU, the main processor accelerometers.
For vibration sensing, I guess?
Exactly, helps with that calibration. And a nozzle pressure sensor, plus an advanced motion control system. It's quite a bit of tech under the hood aimed at speed and quality.
So it's engineered for performance despite the entry-level positioning.
Seems that way. They also mention intelligent print monitoring, like it watches the print.
Yeah, it sounds like a basic camera system maybe to keep an eye on things, perhaps detect failures early.
Could be. A sort of safety net to prevent massive print failures.
Let's talk size. Build volume is 256 by 256 by 256 millimeters.
That's pretty decent, actually, for this class of printer.
Yeah, they give the example of printing a helmet in one piece. Gives you a good sense of the scale.
That's quite large. Opens up possibilities beyond just small trinkets.
And connectivity. Looks like it has cloud options, but also a LAN-only mode.
Oh, that's good. So you can use their Bamboo Cloud service, or if you prefer to keep things just on your local network for privacy, you have that option too.
Nice flexibility. Okay, let's hit some key specs. All metal hot end, max temp 300 Celsius.
Standard stuff for handling common filaments, and even some slightly more demanding ones.
Comes with a 0.4 millimeter nozzle, but others are available 0.2, 0.6, 0.8.
Gives you options for detail versus speed.
Included build plate is a textured PEI plate.
Good all-rounder for PLA and PTG adhesion, and they offer others like smooth PEI too.
Max build plate temp is 100 degrees C.
Okay, that's useful for things like PTG, maybe some ABS, but perhaps borderline for larger ADS prints without an enclosure.
And the speed numbers. Max toolhead speed, 500 millimeters. Max acceleration, 10,000 millimeter sign.
Those are fast numbers, especially the acceleration for a bed slinger design like the A1 seems to be. It suggests quick prints are possible.
Now, filaments. Ideal. PLA, PTG, TPU, PVA. That sounds about right for an accessible printer.
Yep, the most common, easiest to print materials.
But then they list others like ABS, ASA, PC, PA, PET, even carbon fiber reinforced polymers, but with caveats.
Ah, the caveats. What are they?
Basically, because it's an open frame printer and the chamber temp isn't actively controlled or high, it's better for small, low density models with those trickier materials.
Right, things like ABS and PC really benefit from, or even require, a heated chamber to prevent warping and layer splitting, especially on larger parts.
And they recommend a hardened steel nozzle for the abrasive stuff like carbon fiber.
Absolutely essential. Standard nozzles wear out incredibly fast with those. So it can print them,
Hmm.
but maybe not as primary strength, and requires upgrades.
Got it. It also has a low frame rate camera for monitoring and time lapse,
Nice Lestra.
and sensors for filament runout, filament tangles, power loss recovery, even filament odometry, tracking usage.
Wow, that's a comprehensive set of sensors. Really leans into that reliable and easy theme, catching common problems.
Yeah, seems like they tried to anticipate potential frustrations. Couple of final points on the A1. Refurbish units only in China currently. And any units sold after Jan 30, 2024, have the fix for that heat bed cable issue people might have heard about.
Good to know they address that.
And the price, $499 USD.
Okay, so just under $500. That sets the benchmark nicely.
Right. Now let's switch gears to the X1 Carbon.
The big brother, perhaps?
Seems like it. The description immediately shifts. It's about speed, advanced materials, empowering advanced projects.
Okay, different focus entirely.
And the speed boost is clear. Core XY motion system, 20,000 millimeters oxygen acceleration.
Whoa, okay. That's double the A1's acceleration.
Yeah.
And Core XY is generally known for better high-speed performance and quality compared to typical bed slingers.
So that translates to potentially much faster prints in reality.
Oh, absolutely. Core XY means the bed only moves up and down, Z-axis,
Yeah.
while the print head handles X and Y. It's inherently more stable at speed, and that acceleration means it gets up to speed much quicker. Big time saver on complex prints.
It also does multicolor, but using the standard Bambu Lab AMS.
Right, the full AMS system, not the light version.
And the page hints at up to 16 multicolor printing. How does that work? Linking units.
Exactly. You can connect multiple standard AMS units together up to 4, each holding 4 spools to get that 16 material capability. Much more capacity and flexibility than the A1's single AMS light.
Way beyond just 4 colors then. Different materials in one print too, potentially.
Okay. That's a big advantage of the standard AMS. You could mix PLA with support materials like PVA or different types of PTG, etc.
Okay, another big tech difference. Dual auto bed leveling using LiDAR and analog force sensors.
Yeah, that's pretty high-end. LiDAR uses a laser to map the bed surface with incredible precision, the quote, 7-micron resolution.
Which is tiny.
Incredibly tiny. And then the force sensors provide a secondary check. It's all about nailing that first layer perfectly every time. Redundancy for reliability.
More advanced than the A1 system, it sounds like.
Definitely more sophisticated, yeah.
And then there's the AI stuff, AI inspected first layer and spaghetti failure detection.
Right, this is where the X1C really steps into, like, next-gen features. The AI uses the camera to actually look at the first layer as it goes down.
And it can tell us something's wrong.
Apparently, yes. It can spot issues like poor adhesion or defects and pause the print, alerting you before you waste a ton of filament.
And the spaghetti detection. We've all seen those pictures.
Yeah, the dreaded AirPrint mess.
Yeah.
The AI is trained to recognize when that starts happening, when the print detaches and filament just starts extruding wildly and it stops the print automatically.
Okay, those are genuinely smart features. Could save a lot of time and material.
Huge potential savers, yeah. Real set it and forget it kind of features, almost.
Now, materials. This seems like a major focus for the X1C. Hardened nozzle and drive gear included.
That's key. It means it's ready out of the box for those abrasive filaments we talked about, the carbon fiber reinforced, glass fiber reinforced ones.
Which the A1 could do with caveats and upgrades, but the X1C is built for them.
Yes, exactly. It's designed to handle PA, nylon, PC, polycarbonate, PTT, TPU, and especially those reinforced polymers reliably. The hardened components are crucial for longevity when printing those tougher engineering-grade materials.
So if your projects need high strength, temperature resistance, that kind of thing.
Then the X1C is much better equipped for it. That's a core difference.
It also mentions vibration compensation, XY, and extrusion compensation.
More advanced features for print quality. Vibration compensation actively cancels out tiny vibrations during high-speed moves, preventing surface artifacts like ringing or ghosting.
Smoother finishes, basically.
Yeah, cleaner prints, even when going fast. And extrusion compensation fine-tunes the filament flow for better dimensional accuracy and consistency. Again, pushing quality at speed.
Okay, let's hit the X1C specs. Build volume, same as the A1, 256 cubed.
Interesting, so no size advantage there. The difference is purely in the tech and enclosure.
Nozzle is 6.4 millimeter hardened steel included.
Hmm?
Hotend is all metal, 300 degrees C max tempo, same as A1.
So the Hoten temp isn't higher, but the hardened nozzle is the key upgrade there.
Supported filaments, it lists the basics like PLA, PTG, TPU, ABS as also supported,
Okay.
but highlights PA, PC, and the carbon glass fiber reinforced polymers as ideal.
That really drives home the intended use case. It can print the easy stuff, but it excels at the hard stuff.
Build plate surface is random, apparently. Textured PEI or cool plate both work with the LiDAR.
Huh. Okay. A bit unusual, but both are decent surfaces. The cool plate is often better for PLA, while PEI is more versatile.
Max build plate temp, 110 degrees C on 220V, 120 degrees C on 110V.
Okay, significantly hotter than the A1. That's crucial for materials like ABS, ASA, and PC to prevent warping. The enclosed build chamber helps maintain that heat, too.
Right. The X1C is fully enclosed, isn't it? Unlike the A1.
Yes, big difference. The enclosure traps heat, creating a stable, warm environment, which is essential for printing those high-temperature, warp-prone materials successfully, especially for larger parts.
Max speed of tool head, 500 millimeters, same top speed as A1. But the max acceleration is the key. 20 meters a side, which is that 20,000 millimeters SASA number again.
Right. So while the maximum velocity might be the same, the X1C gets up to speed much, much faster, leading to significantly shorter print times overall. Speed isn't just about top velocity, acceleration matters hugely.
There are a couple of notes. Bambu Studio software limits the default printable height slightly, but you can unlock the full 256 millimeter.
Probably a safety margin thing, maybe related to the tool head clearance at the very top, but you can override it.
And the filament cutter stopper might occupy a tiny bit of the build area, just something to be aware of for max size prints.
Minor detail, but good to know.
The X1C box includes the printer, build plate, filament, accessories. The combo version adds the AMS unit, spare parts, cables, more filament.
So the combo is the full multi-material package.
And the price for the X1 carbon combo, $1,499 USD.
Okay, so yeah, $499 for the A1, $1,499 for the X1C combo. That's a significant jump, 3 times the price.
It really is. So let's try and boil this down. What are the absolute key differences for someone trying to choose?
Well, number one is probably the target user and materials, right? A1 is easy, accessible, great for play obtain, good entry to multicolor with AMS light up to 4 colors.
And it's open frame.
Open frame, yeah. X1C is the powerhouse. Enclosed, built for speed with Core XY, handles advanced abrasive materials easily thanks to hardened parts and higher bed temps.
Plus, the much more capable standard AMS system for potentially 16 colors materials.
And those AI features the failure detection, the first layer inspection, that's unique to the X1C.
The leveling system is also more advanced on the X1C with the LiDAR.
True. More sophisticated calibration and monitoring all around on the X1C.
So it comes down to simplicity and affordable multicolor basics, A1 versus advanced speed, material capability, AI smarts, and higher capacity multi-material X1C.
That's a pretty good summary. Now, obviously, the price reflects that difference starkly. $500 versus $1,500 is a major consideration.
You're paying a premium for the enclosure, the Core XY, the hardened parts, the AI, the LiDAR, the standard AMS compatibility.
All those things add up. So you really need to ask yourself, do I need to print engineering-grade materials like nylon or carbon fiber PC?
Do I need blistering speed? Or is the A1's already fast speed good enough?
Do I need more than 4 colors or the AI safety nets?
If the answer to those is mostly no, then the A1 looks like incredible value at $499.
It really does. It brings a lot of formally high-end features like decent speed and multicolor down to a very accessible price point.
But if you do need that advanced material capability, or you're doing serious prototyping or small-scale production where speed and reliability with tricky filaments are paramount,
then the X1 Carbon is probably worth the investment. It unlocks a different level of printing.
also consider the ongoing costs, maybe. Specialized filaments for the X1C can be pricier.
Good point. Engineering materials often cost more than basic PLA or PTG, and if you expand the AMS system, that's more cost too.
So wrapping this up, we've tried to lay out what these two printers offer based on Bambu Lab's own information, the A1 and the X1 Carbon.
Yeah, hopefully breaking down the specs and features gives you a clearer sense of where each one fits.
Definitely think about your own projects, what materials you realistically see yourself using, and what your budget looks like.
Both seem like very capable machines, just aimed at slightly or perhaps significantly different needs and budgets.
Right. And maybe a final thought to leave you with. Seeing printers like these, the A1 making multicolor easier, the X1C pushing speed and materials, where does this take personal manufacturing?
Good question.
What kinds of things, maybe things you didn't think were possible before, on a desktop machine could you now imagine creating? Whether it's for work or hobbies or just invention.
Yeah, what new doors does this kind of accessibility and capability open up for individual creators? Something to ponder.
Definitely. Well, thanks for diving deep with us today.